Hi, Year 10, it's Mr. Green here. I'm going to be taking you through the first 3 lessons of physics you'll be doing while you're off. First off, a retrieval section. If you answer these 5 questions, just pause the video, have a go at them, and do that now. Okay, I'll take you through these answers. So question 1, the equation that links kinetic energy, velocity, and mass is energy equals half times mass times velocity squared. Question 2, the definition of power is the rate at which energy is used, so how quickly energy is used. The more powerful something is, the quicker it uses energy. Work done, power, and time are linked by this equation. Power is equal to work done divided by time, because again, that's energy over time, giving us the rate of energy transfer. Mass, gravitation, potential energy, gravity, and height is this. Gravitational potential energy is mass times the field strength, or gravity, times the height of an object. And the unit of mass would be kilograms, or kg. Our first lesson is on energy transfers. We're going to know what is meant by the conservation of energy and how this links to energy efficiency. And our learning outcomes state the ways in which energy can be transferred and explain how the properties of objects determine whether they are insulators or conductors. First up to start with, we have 2 objects here, 2 pots that are boiling on a pan. One has a wooden spoon inside it, one has a metal spoon inside it. How will the wooden spoon feel if you touch it, and how will the metal spoon feel if you touch it? What we should get to there is if we touch the wooden spoon, it won't be particularly hot. We will be able to use it to stir the pan, but the metal spoon will be really, really hot. This is because metals are better conductors than woods. Insulator. Wood is an insulator, so it doesn't conduct heat as well as the metal. We're going to be looking at other materials and how they measure up. What we're talking about here is thermal conductivity. Break the word down. What does thermal mean and what does conduct mean? Well, thermal is a term that relates to heat or heat energy. So if we're talking about thermals, we're talking about heat. Conduct means to lead, to guide or transmit. So if we put those 2 together, thermal conductivity refers to the rate at which it transfers heat energy, how quickly it can transfer that heat energy. The more thermally conductive an object is, the greater the rate at which it transfers heat energy. So, we've got 4 objects there. If you pause the video and place them in order of which is most and least conductive, most to the left, least to the right. Okay, we should organise those in this order. Copper is the most conductive, then aluminium, iron, and then glass at the bottom. Try and put these in order as well, so place these on the continuum. We have air, gold, concrete, wood, brick, and silver. Place those on that continuum with copper, iron, aluminium, iron, and glass. Pause the video while you do that. Okay, here's the order. It's silver, copper, gold, aluminium, iron, concrete, wood, brick, and air. So in that list, silver is the best conductor. It has the highest thermal conductivity. Whereas air is the worst conductor. It's in fact an insulator. It has the lowest thermal conductivity. It's not just conduction that allows heat to move through objects. Infrared radiation also transfers heat energy. Now, it's a type of EM wave, an electromagnetic wave. Electromagnetic waves don't need particles to move, they just go through a wave. Now, there is a spectrum of infrared radiation, which we can see at the bottom there. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays are our spectrum. We're concerned mainly with this section. This is the infrared section. When energy is transferred at this frequency, it is absorbed as heat and is transferred as heat, and that's one of our main types of heat energy transfer. It's how energy gets from the sun to us. There are no particles between the sun and the earth, so infrared radiation carries that information over to us here. Now, all bodies, no matter what temperature they are, emit and absorb infrared radiation. And the hotter the body is, the more infrared radiation it will emit every second. We can see there thermal imaging cameras, which will take pictures showing the infrared energy that's being released by an object. You'll see from the car there, the body of the car is quite cool, but the engine and the tyres are warm. It's been running for a while, so we can see it's hotter. With the dog, you can see its eyes and its mouth. Much higher heat energy, much higher infrared radiation coming out from there than the rest of its body. The fur, which is an insulator. Now, colour has a huge effect on how much infrared radiation is emitted. Dull, matte, dark surfaces are the best emitters of infrared radiation, whereas shiny, light surfaces are really poor emitters, but they're great reflectors of radiation. So if I had a hot cup of tea and I placed it into a black mug, it would lose heat very quickly. It would cool down really, really quickly. Whereas if I placed it in a silver mug, it wouldn't cool down as quickly. It wouldn't be emitting as much heat, so it would take a much longer time to cool down to room temperature. Okay, 3 questions on there. I'll give you a minute to do those. If you pause the video for a minute, answer those questions, and then restart, we'll answer those. Okay, question 1. Which drink would cool quicker, and explain why? Well, the drink on the right would cool quicker, the drink that's got the black surface on it. This is because black is the best emitter of infrared radiation. It would transfer heat at a much higher rate than the silver one, and so its heat energy would go down quicker, meaning its temperature would go down quickest. Question 2. Thermal mugs have a shiny silver surface inside. Explain why. The silver surface is a poor emitter and it's a great reflector. So if heat energy tries to escape through the form of infrared radiation, it will be reflected back into the cup, keeping the temperature of the liquid inside the cup at the right temperature. Now, not all of it stops it there, so it cools down a lot slower. It will eventually cool down to room temperature, but it'll take a long time. What surface would be best for a radiator, and explain? Well, what do we want a radiator to do? We want a radiator to heat the room. We want it to give out heat as much as possible. So if I was going to paint a radiator, it would be painted black. Black is the best emitter of infrared radiation. It would give out lots and lots of infrared radiation to the surroundings, heating that up quickly. With all this in mind, we are heating our houses. We like to be nice and warm in our houses, so we need to insulate. We spend lots of money each year heating our homes, and it's important that we reduce that heat that's escaping. So very quickly, draw a house and identify all the different ways you can insulate your home. You press pause while you do that and list those ways. Okay, let's continue. Lots of ways of reducing any heat transfers from inside the home. Our main ways are carpets, curtains, draft excluders, which will reduce it, but we have loft insulation and we have double glazing. Your doors, your windows, any areas that are exposed to the outside will have areas where they will lose lots of heat, also through your walls. Now we need to look at ways of reducing that. Radiators often have silver foil on the wall behind them. Why? Well, the reason for this is the silver foil reflects the heat that's coming off the radiator back into the room, and it's not absorbed by the walls. The walls would then transfer it to the surroundings if we left it like that. So it means that the room heats up and stays heated. These are 5 different ways of insulating our house. The first one is just a single brick wall. Second one, we have double glazing, so that's 2 panes of glass with a space in between. Third one is cavity wall insulation. We have 2 brick walls, a gap in between, and that gap is filled with a foam. Fourth one is just a wall with a gap in between it. And the fifth one is just a single pane of glass. We need to put those in order of the most to least insulating. Give yourself a minute to do that. Okay, the best insulator in that case would be the cavity wall insulation. The more effective material is an insulator, the less heat energy it will transfer, so that would be great at doing that. So if we have 2 brick walls, a gap in between, and we place a foam in between there, that will reduce the amount of heat that's transferred. The worst, without a doubt, is the single pane of glass. The single pane of glass will transfer quite a lot of heat through it. Double glazing reduces that quite a lot. If you see, the single pane of glass, it has 5.7 watts per metre squared, so that's how many joules per second per metre go out from there. If we double glaze it, that goes down to 2.7, nearly halves it. So, we need to look at these values. These values are known as U values, and U values help us quite a lot. A wall with a really high U value will transfer more heat, so the room loses heat quicker. If we're looking at any insulation, we want the lowest U value possible. And we can see from the order we place those in which has got the lowest U value, and we can explain that why. So how does the double cavity insulated wall keep a room warm? Well, what we're trying to reduce there, we're trying to reduce both conduction and convection. Conduction is where heat will transfer through a solid, it will transfer through the solid itself and to the outside. By putting a gap in between there, we're stopping that particle from transmitting it to the next particle. So we stop conduction. We also stop convection. Convection is where gases heat and raise. The particles in the gas will get hot and raise and move the energy that way. By putting a foam in there, we're trapping all the air in that wall. We're trapping that from moving. So it won't allow that heat to transfer between anything else. Double and single glazed windows. Single glazed windows, heat will hit there, it will conduct through, and it will move through to the outside. So it will have a lot of heat energy coming out. Double glazing has that gap in the middle. That gap has either got gas in there, or if we've got brilliant double glazing, it will have a vacuum in there, no particles. This will stop heat transfer by both conduction and convection. Okay, our progress check. There are 8 questions on there. Pause the video while you answer those 8. Give yourselves 10-15 minutes. Once you restart, I'll go through the answers with you. Okay, we'll go through these answers. So, number 1, would you wear a black shirt on a hot day? The answer to that would be no, you wouldn't wear a black shirt on a hot day. It would absorb too much infrared radiation and make you a lot hotter. Question 2. What colour car would you prefer to be on a cold day? Much prefer to be in a silver car. That's the best reflector of infrared radiation and would keep the car cool. Question 3. What colour cup would you keep a cold drink in on a hot day? Well, you want that drink to remain cool, so you want to try and stop infrared radiation getting in. So you have a silver cup that reflects the infrared radiation away, keeping that drink cool. And why are houses white in hot countries? You want your house to remain cool, so you want to reflect as much infrared radiation away as possible. White's a really good reflector of infrared radiation, and that keeps those houses cool. Question 5. Why are solar heating panels painted black? We want them to absorb as much heat as possible, so we colour them black because that is the best absorber of infrared radiation. The tile floor feels quite cold on bare feet, but carpeted floor at the same temperature feels warm. Why is that? It's because the tile floor is a really good conductor of heat. As you place your feet on there, it would absorb heat away from your feet, taking the heat away from them, and that makes them feel cold. Carpets are really good insulators. When you place your foot on the carpet, it doesn't take the heat away from there. It's a really poor conductor. So it wouldn't take the heat away, making your feet feel warm. Okay, there's a few materials that make good conductors. What type of materials are all of these? Should have named gold, silver, iron, steel, copper. All the metals that we previously looked at. Metals are excellent conductors of heat. And explain what type of material the handle to a pan should be made of. We should make it of an insulator, such as wood or plastic, that would stop the energy conducting from the metal pan to the handle and make it safe to touch. If we made the handle out of a conducting material, that would heat up to the same temperature as the pan, and it would be really painful when we try to touch it. Okay, finally, what's going on here? We have a lot of black balls being poured into a reservoir of water. Why would they be doing that, and what's the point of that? It's an LA reservoir in Los Angeles. It's covered in 96 million black plastic balls, and that prevents evaporation and contamination of the water resource. Is black the right colour to use, and is there a more suitable colour? Black is the best colour to use in this case. As well as preventing the water supply from evaporating, we don't want the sunlight to hit the water because that can cause a chemical reaction that makes the water slightly toxic. The absorption of black prevents any rays hitting the water, so if we cover that surface with these black balls, those black balls will absorb the energy from the sun. They will prevent it getting to the water. If the water stays at a lower temperature, it won't evaporate, so we'll save water. The water won't move away. And it will also stop the sunlight making this chemical reaction which causes toxic water. Okay, there will be work placed on Educate for you to complete on this topic, so please log in and check on there. I'll be back with another lesson ASAP. Thanks very much. Goodbye.